So today we are going to present on our project design, which is production of ethylene from naphtha. And our company name is so-called Invoker Sendirian Berhad. My name is Liang. My metric number is 198 369. My other three members of my other three group members are one Hanes Sofia binti one Rosman. Her metric number is 197554. Ahmed Salman, his metric number is 195587. Emilia Eliasa binti Perdauskan, her metric number is 198458. And this is me. And this is Hanis, one Hanis Sofia binti one Rosman. And this is Salman. And this is Emilia. So now we are going to speak about the body flow diagram. This is our body flow diagram. The first component is furnace, then quench, cooler, compressor, carbon dioxide remover, cooler, dehydrogenator, demethanizer 1, demethanizer 2, and deethanizer. And our feed is naphtha. Our product is ethylene. Final product is ethylene. Our feed takes in 122,333.065 kg per hour, and our product ethylene is 50,000 ton ethylene per hour. So if we convert the ton into kg per hour, ton per hour into kg per hour, we'll use 5,727 kg ethylene per hour. So now I want to talk about the project designs unit. Now, the first component is furnace. The furnace is a device used for high temperature heating. High temperature in furnace is needed for cracking process to occur. Cracking process is a process in which heavy hydrocarbon molecules are broken up into lighter molecules. So this is an example for the furnace. Example picture of furnace in engineering industrials. So as you can see, the temperature and pressure for the input and the temperature and pressure for the output. This one is for the molar fraction, and this one is for the molar flow rate. The components are lesser in the input than output. So as for the input, we put in carbon dioxide and naphtha. As for the output, we have these components. As this is the reaction for the cracking process, this is the selectivity for these components, and the ethylene percentage conversion is 40%. And these are the extra information: the average molecular weight of naphtha, mass flow rate of naphtha, molecular weight of coke, and ratio of the carbon dioxide of steam to ethene is 0.5 kg to 1 kg. Ratio of coke formed to naphtha is 0.001 kg to 1 kg. Now I want to give Salma to continue the presentation.
Now I'm going to talk about quench. So the component and the composition are the same at quench. There is no reaction like furnace. So quench is device which the rapid cooling of workpiece in water, oil, or air occurs to obtain certain material properties. In our case, we use water to cool down the temperature of the workpiece. This is the example for quench. And as we know, this is the temperature for inlet for quench, and the pressure. The temperature is 865 Celsius, and the pressure is 2.15 bar. And this is the temperature for the output for quench. The temperature is 349 Celsius, and the pressure is 2.15 bar. As we know, the component and the composition are the same in the quench. So now I will pass for Amy to explain his part.
Okay, now I would like to explain about the cooler. A cooler is a device to further reduce the temperature of the workpiece, but it will not change the compositions and the compound of the material. These are the examples of part of the cooler in the industry. After that, we have a compressor.
So now I'm going to talk about compressor. A compressor is a mechanic device that increases the pressure of a gas by reducing its volume. The pressure is increased so that the next unit, which is the carbon dioxide removal, will have high efficiency to remove the carbon dioxide gas. This is the example for compressor. As we know, the temperature for compressor is 40 Celsius and the pressure is 2.15 bar. And the temperature for the output compressor is 40 Celsius and the bar is 20 bar. The compound and the composition are the same in the compressor.
Now, I will like to explain about the carbon dioxide removal. Carbon dioxide removal is a device which will remove carbon dioxide from its input. The carbon dioxide must be removed because it is correct the system of the dehydrogenator, demetanizer, and deethanizer. These are the samples of the picture of the carbon dioxide removal. Okay, for carbon dioxide removal, only carbon dioxide compounds was removed from the stream. Okay, from the input. The inputs they have a 0.01 carbon dioxide, 0.02 carbon dioxide mole fractions, and at the end of the streams, the output stream, which is only have 0.002 mole fractions of carbon dioxide, which is they have 90% of carbon dioxide have been removed from the compound. The efficiency of the carbon dioxide removals is 0.9, which is the conversion is 1 MEA is equal to 0.410100 carbon dioxide. Okay, the use of the amine is to absorb the carbon dioxide and remove it at the amine regenerator. At the amine stream, they have a 65 bar, which is the high pressure. High pressure is needed for the amine to absorb the carbon dioxide. So it will have a higher efficiency. So it will absorb the carbon dioxide and it will release carbon dioxide at the amine generator. Now I will let you explain the cooler 2. Cooler 2 have the same functions of the cooler 1, which is it will only reduce the temperature of the stream so that it will have the efficient temperature at the dehydrogenator. Okay, this is the function.
So I will explain about the dehydrogenator. So the dehydrogenator is a device which we want to remove the hydrogen gas and the other undesired gases that have the same range of boiling point as hydrogen gas. Dehydrogenator part. So in the inlet stream we have temperature of 150 degrees Celsius and the pressure is 15 bar. Okay, and we have this composition. In the fluid gas stream, which is here, we have temperature of negative 120 degrees Celsius and pressure of 36 bar, and also hydrogen. So the flow rate is 97.174 kmol per hour. And for the undesired, this is undesired stream, and this is we want the stream for the demetanizer. So at this stream we have a temperature of negative 178 degrees Celsius and pressure 25 bar. So still have the CO and CH4 here because we only remove 100% H2 here, and the molar flow rate is the 2002 and 11.113996 kmol per hour. So we use the TBP to know the mole fraction of the gas stream. So next is the first demetanizer and also second demetanizer. I will explain. So demetanizer function is a device which separates the undesired methane and carbon monoxide from the desired stream. So for the first demetanizer, we actually wants to remove the carbon dioxide and CH4. But so in the inlet stream, we have the temperature of negative 178 degrees Celsius and pressure of 25 bar. So the molar flow rate is 2002.11 kmol per hour. And for the gas stream, the temperature is negative 100 bar and 22 and negative 100 Celsius and 32 bar. So the molar flow rate is 49.193 kmol per hour. So there's some typo here, should be negative 100. For the stream, we have temperature of negative 178 degrees Celsius and also pressure it is 18 bar. And this is the composition and the molar flow rate of each compound. So we also use the TBP to know the mole fraction of the gas stream, which is methane and carbon dioxide. So for the second metanizer, here we want to remove all the CH4 from this process. So the inlet stream we have negative 100. The inlet stream is negative 178 degrees Celsius and pressure operates at 18 bar. The molar flow rate is 1952.99 kmol per hour. So this is the composition and this is the molar flow rate. And for the andesite stream, which is the gas stream, we have the temperature of negative 100 degrees Celsius and pressure of 32 bar. And the molar flow rate of the stream is the same as it's not like same, which maybe some error. It's 57.361 kmol per hour, and we remove one kmol CH4 kmol. And for this stream, this stream have the temperature of negative 43 degrees Celsius, pressure of 9.5 bar, and the molar flow rate of this stream is 1895.63 kmol per hour. And this is the composition, and this is the molar flow rate of each compound.
Okay, now with the last unit of our project design, which is the ethanizer. The ethanizer is a device which separates the carbon 2 compound, which are ethane and ethylene, from the C3, C4, and C5 compound that are in naphtha. These are the picture of the ethanizer in the industry. Okay. For the input stream, they have a temperature of negative 43 and the pressure of 9.5 bar, which is the efficient pressure to remove 0.999 kmols of ethylene. And at the second stream, which is the output stream, the second output stream, we have there have no ethylenes produced, but we have the ethane and the other products. The pressure, we are using this because we are using the TBP, which is the temperature bubble point, to get 0.9, as I said before, to remove the ethylene.
So now we are going to talk about costing. Our total cost is now we're going to talk about our total cost feedstock. Our raw materials are naphtha, carbon dioxide, and monoethanoamine. The amount required for naphtha is this amount, carbon dioxide amount is this amount, and the monoethanoamine is this amount. So the total amount is 1559789.25. The unit is in ton. The maximum unit for naphtha is this value, minimum price is this column, and total for the maximum price is 2000, almost 2000, and the total for the minimum price is mostly like 1800. The currency is USD. The maximum cost is the maximum price times with the amount required. Then you'll get the maximum cost. So the total of the maximum cost is the sum of the column. So the same goes to the minimum cost, and the currency is also in USD. As you can see, this one is called the naphtha price forecast. We are using a graph based on 2015 to 2025. And as you can see, the dark blue line is a naphtha price. So the lowest naphtha price is in 2016, which is 390 USD, and the highest price is in 2020, which is 760 over here, okay, USD. Okay. Okay. For the total cost for our product is our products are ethylene, pentane, and butane. Initially, we sell ethylene, but our profit is negative value. So we add on pentane and butane so that we can manage to get back our revenue for our maximum cost. So the ethylene amount produced is given 50,000, and this amount produced of pentane is this amount. Okay, the amount of butane is this amount, so the total is this amount. The maximum price, okay, this is the minimum price total. Okay, currency is in USD. Maximum sale is the maximum price times with the amount produced, and the total is the sum of columns. Same goes to the minimum sale. The currency is in USD. So this is the ethylene price history. This graph is too long, so we just assume we use the 2008 to 2018. So the lowest price is in 2009, which is here, which is 390 USD. The highest price is in 2014, which is 1,600 USD over here. The maximum profit we got is 278,722,233.1 USD, which is 278 million USD. The minimum profit we got is negative 345 million USD. So we got our revenue back. Thank you.
As the conclusion, by feeding your 10 hundred thousands of ton naphtha each year, Invoker Sdn Bhd, which is our company, can produce 50,000 tons of ethylene per year, which we can gain a profit from it. Last but not least, recommendations. The problem is the costs are very high. So to reduce the cost, we are adding the recycle stream in the process. It will reduce the needs of naphtha, which affect the cost, and also can reduce the undesired product value to make it in use. Our company needs to find another supplier that sells naphtha in a very minimum price so that we can reduce the cost. And also, the waste from the process is not handled properly. So the recommendation is in the future, the filter unit need to be added. Hence, the water will not affect the environment safety when it is released from the process. That's all from us. Thank you.